where you can ask any questions you like at any time you like, and then at the end of the demonstration we'll go through all of them and make sure you get an answer, whatever it is. So if anything comes up during the time, just pop it in the questions and answers section. And otherwise, sit back, relax, and let us tell you about the latest Snapt product, Nova. This will also be available as a recording, by the way. If you want to share it afterwards, you should get a copy once the recording has been processed. So, welcome to our webinar. We're going to be looking at how DevOps and microservices are changing things, and especially how that is causing challenges in our market, the ADC load balancing market, with these modern environments, and how our new product Nova aims to solve these problems, how it's being used by DevOps and IT Ops to achieve that, and how modern pricing models work with Nova, and then finally the primary point of this demonstration of actually using the product. So the core kind of philosophy behind Nova is that existing ADC solutions in the market don't provide the scalability and flexibility needed today. When we say this, we're talking about things like cloud native, Kubernetes, multi-cloud, multi-site ADC, the trend today where people are having many more solutions versus fewer, also often called microservices. So even at Snapt, we felt that ourselves. In the beginning, we used to often see, 2 ADCs at a client, up to 4, up to 6, up to 8. Someone with 10, we would call a large client. Now we have clients running 200, 300 ADCs in production. And this is going to continue to grow, right? We've got certain clients that we're speaking to that are estimating there could be between 4,000 and 5,000 ADCs in production within the next few years. So alternative cloud native apps that are designed to address this kind of thing don't provide the reliability, visibility, and power of traditional ADC. And this is where people find themselves stuck between sort of a rock and a hard place between the two types of solution. The product we're looking at today, Nova, does both of these things, right? So it's designed to deliver the traditional ADC value that people have come to know in a modern environment at scale. And that's what we're going to have a quick talk about and then have a look at. So let's expand on today's problem a little bit. And we won't get into too much detail, but as we all kind of know, the approach to networking for the last 20 years is dying quite quickly. And that's driven by things we already understand, are comfortable with, like the migration to cloud and VMs, obviously, but essentially the death of static servers, racks, and data centers as we know them, and especially the static component of that. And we're seeing that even with VMs. People are scaling up and scaling down. They're auto-scaling their services. On Black Friday, they need a lot more servers than they do on a random Tuesday, and they shouldn't have to run those all the time, etc. The second thing we're seeing a lot is that tech specialties are being replaced by DevOps and or modern IT Ops, which is changing the ownership and responsibilities of the platform a lot. So in the past, you would have an ADC engineer, a guy who just did load balancing, and they would be responsible for the load balancing infrastructure in a business. More and more now we're seeing at small businesses, medium businesses, and large enterprise that this is rather a team that is more of a jack of all trades than a master of one, right? And it's really driving this need for a lot of automation and ease of use and things like that. The requirements for horizontal scalability at a massive level, scale in and scale out versus static. So that's what I was talking about. It's a concept that today has reached a point where people understand it as meaning, well, I might have 4 web servers in production now, and during a spike of traffic, perhaps I'll boot up another 4 to handle that. And in a big example, maybe you've got 20 web servers and you want to boot up another 10, and you think, well, I need 2 load balancers instead of 1. What we're seeing at some of our larger clients, when we look at things like hyperscale, is this problem at a massive scale. So where you may have, 500 servers now, and you might need 10,000 servers later. And this kind of massive growth of scaling out and scaling in versus just like a static setup is very difficult to solve today, especially when you look at some of the biggest sites, and the traffic they might get over things like I said, like Black Friday or Cyber Monday, Christmas time traffic, stuff like that, or in retail or like news. News is a great example. You might have a medium-sized publication that breaks a story and they receive 100 to 1,000 times more traffic than they traditionally do. How do they scale up to handle 1,000 times? Things are becoming much more dynamic, less static. And this has led to a massive need for automation, agility, and this like flexible mesh of systems, send the traffic to the servers that are online, expand the ADC if it needs to be, etc. And that's obviously the rise of service discovery and agility, causing problems for load balancing vendors. So something we've always done at Snapt is discover backends like, AWS servers or things like that. This is really becoming more and more of a demand today. So what is needed? An entirely new way of ensuring application delivery and scalability. So dynamic self-scaling ADC deployments, right? That have no physical limitations. So you could have 2 ADCs now, and on Monday you might need 1,000 to handle that amount of traffic, and you should be able to do that. A focus on DevOps design. DevOps is a funny word. It means a lot of things to a lot of people, but to us, it means this kind of, more modern way of deploying applications and looking at things as a service, caring about the whole stack, automation, controlling things via API a lot of the time, stuff like that, right? The ability to scale in and scale out, we spoke about that a lot, but also global load balancing built in should be native so that you can, achieve true hyperscale across multi-cloud locations or multi-sites. Direct service discovery, so integrating with things like Kubernetes, Rancher, Docker, AWS, Azure, Console, etc., in order to actually discover what servers you have online, what containers you might be running, things like that, and powerful AI security to detect threats and security and performance. Now, Nova can run millions of active ADCs in parallel. So the limitation on performance with Nova is extremely high, obviously, and its general aim, if you think of it as a principle, is to move the value out of the data plane and into the control plane, right, when you look at your ADC. So right now, if you've got a single ADC doing your load balancing, sitting in a data center somewhere, its configuration, the data it has, its information, it's all stored there sitting in the rack, just like it might be a switch, or a router or a router. And all of that kind of value sits there, and that equipment becomes valuable, and you need to start worrying about high availability or disaster recovery or failover, and you need to start replicating configs and things like that. Nova fundamentally changes that by saying, well, you configure everything in the Nova cloud application and then deploy that to locations however you see fit, right? And an individual device in a location has no real value anymore because it can easily be reproduced. So it allows us to provide this dynamic self-scaling ADC that's basically automated and lets you see all of your data in one place. And we'll go into some examples of that when we actually look at the product. So in real terms, in the real world, Nova is the fastest and most scalable ADC platform in the world. So we can communicate in parallel with several million ADCs at the same time. It allows you to easily deploy to or grow into multi-cloud, multi-site architectures. So you can take an ADC, deploy it into Azure, then say you also want to deploy it into Amazon. You want to route your traffic to both data centers. If one fails, switch it over, all of that kind of stuff with a single configuration. You can automatically scale out that infrastructure. So we'll actually see an example of that today, scaling out due to load. And also scale it back in. So, if you need 4 ADCs during the day and you're sitting in AWS, EC2, something like that, or Azure, DigitalOcean, whatever it might be. When you don't need them, you can scale it back in and stop paying for that compute time. It has a disruptive SaaS model, so you pay for what you need when you need it. There's, it's month to month. You kind of control how you pay. And you host and control all your infrastructure and deployed ADCs in your VMs, containers, or cloud tenant. So it's not a CDN. You deploy ADCs into your environment like you traditionally would with a vendor like Snapt or F5 or whoever you might be using, but you control them centrally. So a couple of highlighted kind of areas for people that identify with the DevOps side of it. It's full REST API, automated service discovery, supports all of your container platforms, clouds, things like that. We've spoken about a lot of these things, but obviously a big focus on scale and automation. And for enterprise, it allows you to operate at true scale, right? So launch and control hundreds of thousands of ADCs from a central location in seconds. Integrates with all of your modern platforms, detects anomalies, threats. You can, mirror threat patterns across your entire organization. So if there's an attack in New York, you can block it at the same time in London, things like that. It's really this kind of central control for what is ultimately now becoming, the most important component in the availability of your services and platform. So a powerful full service ADC for today and tomorrow. And you can be up and running with Nova in minutes. You can sign up after this, if you like, on the website, which I'll show you soon, for a trial. And during our alpha, which is where we are at the moment, you can actually use the product unlimited for as long as you need during the alpha window, which lets you really get a good feel for it. Otherwise, you can set up a demo with us, set up a call with us after this, whatever you need. Now, demo time. We're going to switch over to my web browser, and I'll take you through the actual platform, and we can have a look at it all. Remember, while we go through this, and also after the presentation, that if you do have any questions or anything, you can pop them into the QA section on the webinar. I'll just switch my screen quickly. Great. So here you're seeing I'm on nova-adc.com. This is the website. At the top right, you've got a login button. And for me, that's going to log me straight in. Otherwise, from there, you can register and create an account as well, obviously. Now, what we're seeing here is the cloud control panel where we run everything from. And there's a couple of key concepts that are important to mention first. And the first one is nodes. So a node on Nova is an individual instance that we can control. So what is that? It's either a server, like a piece of hardware, tin. It's maybe a VM or a container or a machine in a cloud environment that is running the Nova client. So when we install, you'll see, we'll do an example now. You can install the Nova client onto a system. That allows us to control that system in order to deploy, manage, run ADCs on it. So essentially, it's your ADC is a node, but obviously you can run multiple actual ADCs on that node. For example, you might want one on port 80 and you might want one on port 25. There's two different ADCs. So a node is an individual server. Then on top of that node, we'll set our ADCs that actually do the job we want, right? Load balancing, web acceleration, and the application firewall. So the first thing I'm going to do is create a node just to show you how that looks. Now, if we come in here, you can see we've got some example nodes on this account, but down here I can say demo node and create one. What that will do is issue me with a node ID and a key. And that identifies this system and allows us to control whichever system is running the Nova client with this node ID and node key. So you can see there's a couple of options for installation here. You can install it as a doc image, so you can put it straight into your container platform. This is just an example for how to run it, but you can see it's Nova ADC / Nova-client. You can do a scripted installation, so you can run this on any existing Linux server to automatically install it. After you run that, you just control Nova through the interface. Manual installation in case you need, and you can also download and use VM images in the near future. We're busy preparing those still, so you'll be able to run them just straight as a VM. But otherwise, for now, if you don't want to use a container, you can just install any flavor of Linux you like, for example, Ubuntu, and run the install script on it, and it will install this node for you. Now, I'm not actually going to do that because we'll see here this node is still in status unknown. We can deactivate it and then delete it. What I want to show you is launching through a cloud account. So if you're using a cloud provider, for example, Amazon or DigitalOcean, you can come here on Nova to Cloud Connections and link up to that account. So when you say create, you can see you can choose to put in your API details, and we can then access that cloud account. And that lets us do a bunch of things, from service discovery, which I'll show you just now, to being able to launch instances into that cloud. So here, for example, we have test AWS and test DigitalOcean. Today, I'm going to launch these demo servers in this DigitalOcean account, because you'll see in here we also have two web servers set up, little test web servers for this that show basically just a hello page. You can see here. And we can see all of our servers in our DigitalOcean account here. You can see the email address for it, etc. And we can launch servers as well. So for example, I might want to say, okay, I need to create a load balancer in DigitalOcean. This is my account. I've got my two web servers and I need to load balance them. So I might say basic LB. and I can launch them, in whichever location I prefer and whatever size of instance I prefer, right? So, obviously you're paying the cloud fees. So as you go up, the price of the cloud instance goes up. But here we'll just use the basic $5 a month droplet at DigitalOcean. And you can choose the number you want to launch. So I'm just going to launch one now because soon we'll do an autoscaler where we can see it launch many, but you could launch as many as you wish here at the same time. This will automatically launch a new instance on your cloud for you, which will then install Nova and be up and running, and we will be able to control it from here. So depending on the cloud provider, this can take anywhere from 10 to 60 seconds. AWS is about the fastest, and DigitalOcean is probably about the slowest. It might take probably 30 to 40 seconds. But what we're doing here is launching this droplet that you configured, the 1 CPU, 1 gig of memory droplet. Then once that comes online, we'll install Nova to it. It will connect to the cloud platform and we'll be able to control it. So you can see it's launched now and we're installing Nova. That's the next status. And then after that, we should see at the top right of my screen will pop up a little message saying that the node is connected as soon as the installation is done. Again, this really shouldn't take much longer than this. And if we refresh afterwards, yeah, there we see basic LB. That's the new server that we've been launching on the cloud. So this should be finished any second now. Just want to wait for it on this page. Obviously, you don't actually have to stay here on this page. There we go. And we can see it's changed its status to online. So we can now see that node. And we called it basic LB. And here we see it. So it's connected, it's online, and we can have a look at its information. So all of this information is being fetched live from the server, right? Without any connection to it. We don't require SSH connection or anything. The client connects out securely to our cloud. So we don't have any direct connection to it now that it's online. And you can see we've discovered things like its IP address, memory usage, CPU, some of its specs, its location. You can see where this DigitalOcean server, New York 1, is sitting there, and some information about it. And we can start to monitor, its CPU usage, whatever we might want to do. We can give it tags and so on. But basically, we have an instance now, a server, which is considered a node to us, called basic LB, that we can do things with. You can see 100% CPU usage now because it's obviously still just booting up and configuring everything, installing things and so on. So now I want to load balance using that new server. Like I said, we've got 2 web servers in our cloud account, and we want to create a load balancer for it, right? Web server 1 and web server 2. Now, one of the things you'll see on this page is that they've got tags. So in DigitalOcean, you can tag servers, web servers, right? They're both given a tab called web servers. So the first piece in creating an ADC here is to create a backend, to say where should the traffic go, right? When we decide to send traffic to upstream servers, in our example, web servers, where should that be? So I can say here, demo web servers is going to be the name of this. And you can see I've got a couple of options for how to discover those. So the most basic is simple, right? I could add a simple one and I can put IP addresses in, like we know, any normal ADC to be, right? So I might say, well, it's 10.10.0.100 port 80 and 10.10.0.101 port 80. Those are my servers, and that's how I want to do it. And I could save that, and we would then, this demo web servers group would send traffic to those 2 IPs. I don't want to do that though, because I'm using a cloud connection here. I want to do some form of service discovery. So what I'll do is say use a cloud API. And here I'll say demo web. And let's add a cloud API connection. So what this does is, instead of us specifying the IP addresses that we're going to send traffic to, we instead specify a way of discovering those IPs. So we can say, okay, send traffic to it on port 443, it's SSL, and look on our test DigitalOcean cloud connection and send the traffic to the tag web servers. Now, if I save this, we will automatically discover that tag and see what's in it. And here we see those 2 servers that we pre-configured, right, our 2 web servers. And anytime this changes, if someone has access to the DigitalOcean account, someone in your organization, and they launch new servers, they tag it with web servers, it'll automatically be brought into any ADCs you're running that are using that backend. So it pulls it the whole time and gets updates automatically. So you no longer have to go back to the ADC and say, oh, I've launched more servers, I better put the IPs in, or I better take the IPs away. You can just control it via service discovery. And there's a bunch of different methods for doing that. In this example, like I said, we're using the Cloud API one. So the next thing we want to do is actually create an ADC now. So let's say, okay, this is going to be for our demo website, right? And we could say HTTP, HTTPS, RDP, TCP, you can do anything you need. But for our example, we'll say SSL termination. So we want to run on port 80 and port 443, and we want to be able to read the traffic. So we want to terminate SSL. Reason for that being that we want to do things like the WAF and caching and all of that kind of stuff. So if I submit this now, then we get to configure this SSL ADC. And you can see the regular kind of options you expect to see here. We can change things around. We have to select the SSL certificate, of course. I'm going to select the snapt.net one, which is later going to give us an error because we won't be going there with a .snap.net address, but it will work once we accept that. Then you've got your listen and backends. So you can say here, okay, I want to send this traffic to demo web, right? That's our Cloud API backend. If we go in there, you'll see here, this backend that we set up, sitting on the DigitalOcean cloud account, and we're discovering it based on web servers. So we'll send the traffic there. Can do our health checks. How do we want to check the health of the site? What are our rise and falls? How often to do health checks? Your standard stuff like that. And then our performance and security page. So you can limit the maximum connections, the connections per second to the server. So maybe we want to say, well, let's just do 10,000 connections. We can turn on caching, for example. We can redirect HTTP to HTTPS. So like I said, we're going to send SSL data through. So let's turn that on. Let's also re-encrypt SSL because we said our service port was going to be port 443. And we know this is public cloud, so we'll want to keep things secure across the wire, right? So when we terminate, we'll manipulate the data and then re-encrypt it before it goes to the backend if we're going to send it back out. Security, we're going to enable the WAF, our application firewall. We'll go through that in a bit. You can also enable things like bot protection, flood protection, post protection, and scanner protection, right? So these protect the site against web scrapers, HTTP floods, post request spam. So, like brute force attacks, for example, vulnerability scanners. So for example, the vulnerability scanners, what that will look for is an increased error rate, an abnormal error rate on your servers. So we monitor the reply rates of all of your upstreams as well. So if we pick up one of your web servers responding with a whole bunch of 404 errors, far more than it should be, then we know most likely this is a vulnerability scanner and we can block it, for example. We can also manipulate headers, so we can add things like, XSS protection for cross-site scripting headers, all of that kind of stuff. We can secure cookies, we can block referrers, we can enable HSTS, but I'm not going to do that, and so on. And we basically are now configuring this ADC, right? What configuration do we want it to have? And we've set this up now. So we've said, okay, we're listening for port 80 traffic, HTTP, and port 443, SSL, and we're going to send it to the backend that we created earlier. But what we've really done is just create a template that can be attached to any number of nodes, because this is not actually functioning right now, right? We've just configured it. We haven't put it on our new node yet, this node that's still sitting here. So if we come here and look at it again, this basic LB0, we can now actually deploy this to, right? So if we come back in here, we say, it says no nodes are attached, please deploy this ADC. So what's nice here is that you can deploy it based on tags, or you can deploy it based on a select number of nodes. So for example, you might want to have it deployed to 5 servers in the same location, or maybe to New York 1 and San Francisco 1, or to your AWS cloud and your Azure cloud. You want to deploy the same ADC. You want to see its stats in one place, but you want to monitor it, etc. And you'll manage it all in one place. So once you tag nodes, you can also do it based on tags that you've assigned. In my example here, I'm just going to put it on our one load balancer, this one that we set up together, but I'll show you an example of one with 2 just now. So once we say attach, this is going to attach this ADC to that node. And that then that sets up the ADC, etc., to be ready to run on that node. So if we come in here now, we'll see basic LB0 is running, and it should have 2 servers when we come in, demo web 0, demo web 1. So remember, this has been automatically discovered, right? All we've done is we've said we want an ADC that sends data to our web servers tag at DigitalOcean, and we want to deploy one into DigitalOcean. Then we attach that ADC to basic LB, and it's set it up, and it's ready to go. So you can see the speed at which it communicates with these servers is obviously very quick, right? This is all live straight from the server that we're getting this information. And once we start to get some data, you'll see ADC requests are populating here and so on. So everything is online, up and running. And if we look at like our partner site, for example, you can see here we can actually see some data, flowing through a large number of blocks because we do tests on that site. The latency, so you can monitor response times. You can see attack statistics, the performance of your application there. So I can say, well, I want to see what's the profile of my response time, for example, and how the app has been performing, basically. Now, this is all managed automatically, and if I make a change, it will deploy that change automatically for me. So here, for example, I might say, well, I want to change my maximum connections to 20,000, for example, and it will make that change automatically. So we just save, and any ADCs, any nodes that this ADC is attached to will automatically receive the updated config and be running straight away. So you can see, because it's reloading, 1 out of 3, because it's doing the health checks, and now they're all online. And this is the ADC that's running in our cloud account. So this would be on-premise in your data center, in your VM environment, or in your cloud tenant or your container setup. Now, this is ready to go. And if we have a look at our node, we should be able to send traffic there, right? It's a server, it's an ADC, it's got a load balance on it. We can send data to it. So we can come in here and see, well, what's its IP? And let's try go there and see if it works. We should receive an SSL error, because we've got an invalid certificate, as I mentioned we were going to have, but we can proceed, and then we should get, the WAF has forbidden us. The reason for that is because we're using an IP address instead of a host name. So the WAF by default assumes that this is a bad request and blocks it. We'll get around that in a second, though, don't worry. So we now will also have some stats on our ADC. So again, you can see all of this data just centrally from your control panel. We had 3 requests, 2 blocks. Obviously, one was probably a fab icon or something like that. And you can start to see all of that live data here. And we'll start to profile how many responses for each server, and things like that. These were all sitting on the front end because the WAF blocked it, obviously. So none of the servers got the traffic, but we'll fix that soon. So now the next thing that comes up is, how do you do this? How do you route people to this server? So what people will normally do, well, actually, let me whitelist that rule in the WAF quickly. So I'm jumping around a little, but I want to just allow us to get to that site by using an IP address. So I'll come into WAF blocks, and don't worry, we'll come back here soon. But I just want to see, okay, that rule ID, I'm going to whitelist that rule so that it doesn't block us for using IP addresses, basically. And we can whitelist that. That should roll out to all of our servers. Sorry, I must go back to ADCs. And we can then hopefully get to the site. Yeah, and we do. So now we see Snapt and we see hello. So we can get there fine, and we can see that data. And we should be able to see also our requests now, by the way, some data transfer. You can see bytes in and out. You can see we went to the first server there and some latency, etc. Now, what we need to do is send data there. So what we would normally do is you would go to your DNS and you would say, okay, well, www.mywebsite.com must now point to this IP address that we have there. And that's perfectly fine. But in the example where you have multiple nodes, let's say you have 2 active ones, or you have nodes in multiple sites, you might want to say, well, I want to route traffic to both sites, and I want to do DNS checks, and I want to do health checks and everything, and then send the traffic like that. For that, we have destinations. So with destinations are highly available, fully qualified domain names that allow you to route traffic to nodes through DNS. So what we can say here is we can say, well, this is our demo website, right? And we'll say demo web. And you'll see it's going to give us, so Snapt is our organization name. Your organization name would be there, .novadestinations.com. So it's going to give us a URL, demoweb.snapt.novadestinations.com, which will respond with something. And here we choose what that something is, right? So here we can say, okay, respond with basic LB0. And I could say respond with a whole bunch, and then do HTTPS health checks and check that port 443 is available. Otherwise, don't send that data. Now, in our example, obviously, we're just using this one, but we'll do a bigger one soon. And we can say, cool, submit. So what we get given now is this demoweb.snapt.novadestinations.com domain name that is this highly available GSLB endpoint for us to send our traffic to. So now instead of saying www.ourwebsite.com goes to an IP, we say it goes to this domain name. And that lets us then control that here and do health checks here and send it to multiple cloud locations here and so on. And you can see we can get stats for that now as well. So we can see, what are queries per second, what's the performance, what's IPs are online, and things like that. And if we go to demoweb.snapt.novadestinations.com, it will be online already, and we should see the same SSL error because it's a bad certificate, and then we see this web page. So that's automatically directing us there, and any changes we make here to additional nodes and things like that will be picked up automatically. So we've got this live ADC now. It's in production, it's running, it's working, it's sending our traffic through, etc. And we can see even more of that data here. We can start to look at node IP rates, for example. So you should, let's hope we just see me. That's my IP address. And we're a safe request, right? So we can start to monitor all of that stuff. And that brings us into the WAF. So the application firewalling and protecting of this web service, right? Basically, if there's a malicious request that comes here, we want to block it. So how do we test that easily? We might have something like test equals hello in the URL bar. But what if a malicious attacker tries to do an SQL injection or a remote file inclusion or something like that? A good test, if you ever want for a WAF, is to send etc password through and see if it blocks it, right? Because that's obviously a malicious string that should get picked up. So here we see that's been blocked because we have found this string in there, which shouldn't be there. And if we have a look at our threat center here, we'll see that we've got the ability to have a look at our WAF. So we can come in here and see what was blocked and why. So 17 seconds ago, we blocked this request because it had remote code execution, Unix shell command found. You can see there, etc password was found in the request, right? To demoweb.snapt.novadestinations.com, which is this URL we put in here. And so that's the entry point of the WAF, really. Now, when we look at the WAF, you've got a bunch of settings, right? You set your paranoia level for how strict you want the rules set to be, a couple of options like argument lengths and things like that. You've also got web app settings. So you can say, well, I'm using WordPress, so tune it for that, things like that. You've got HTTP blacklisting. So you can put in a project honeypot blacklist key here. And you can then use that in order to block suspicious IPs, harvesters, so people that are doing web scraping, things like that, spamming IPs, even search engines if you want. Obviously, that's a very specific use case. You've also got your IP reputation and DOS protection. So IP reputation is calculated based on how many bad requests a client sends. So if you're getting a lot of blocks, an abnormal amount of blocks, more than everybody else is getting. For example, if you were doing a scan or trying to exploit something on the server, then you would automatically be blocked because your reputation deteriorated. And the same works for DOS. So what it does is it profiles how many requests you sent that are dynamic content. So not JPEGs and GIFs and style sheets, but to actual pages within a time slice period. And then it will block you if it needs to, if it detects abuse, and you can configure that. And then you've got your threat center when you can see the summary of all of this. So here we see all of our live nodes, and we're in communication with them, right? So we can see their HTTP error rates, how many blocked hosts they have, black hole hosts. So a host will get blocked if they're abusive, and if they're attempting a denial of service attack, they'll get black holed, right? Because obviously that's a much higher efficiency if we just drop the traffic instead of actually respond to them. And we're monitoring the error rates and all this kind of stuff to essentially watch for threats. And you can see your risk map. So, where are the top risks coming from, and where's your throughput coming from, and, how does it work out by country, etc., and monitor that all from here. And this is all getting the information live, so we can see all of this information at any time. And for example, we can see this one has 2 blocked hosts, so we can come in here and see what those are. And we should see that there's probably, 2 blocked scanners, right? So this is a test host. We run a scan against it the whole time. You can see here we've picked up 28 HTTP errors a second this IP was generating, and so we've blocked it as a scanner. So it's no longer sending traffic. This IP, on the other hand, is safe. And you can monitor for that kind of thing, see that sort of stuff, and so on. And it will pick up any anomalies, right? So what I'm going to do in another tab, which you won't necessarily see, is I'm going to run a quick scan against this IP address that we have here. Let's just see if it'll start. Yeah. So I'm running a vulnerability scan, basically. Just like a script, that anyone would run. Probably the first kind of vector of someone trying to do an attack is looking at what's, running a scan basically and seeing what they can find. And if we come in here, we'll start to see the request rate go up, right? So here we've got a peak request rate now of 7. And as the scanner ramps up, we'll see more and more of that, and we'll see more blocks and more denies and, so on. So here we've got 10 blocks now. It's starting to pick up that it's blocking traffic, right? 13 blocks, and so on. And we can watch that and see as it sort of goes. If we get some real requests here, we'll get, I want to go to the real page, then we'll start to get some data. So we can see some of its requests coming through. It's going quite slowly at the moment, obviously. It's just, a local tool. It's actually called Nikto, if anyone ever wants to use it. But we can see, now we're up to 37 blocks and so on. And if we go back and look at our threat center again, we should pick up that there's now a problem, right? So we've got WAF blocks on this host. We've got an HTTP error rate of 53. Coming out of South Africa here, we have a threat, right? So you can see in South Africa, we've now blocked one host. That's where my IP is coming from. And if we have a look at this, we should see that IP address now being blocked for being a scanner, which we do. And so now I can't get here at all, even if I send legitimate requests, because I've been detected as being, an abusive source of traffic, right? And blocked, basically. So I can stop that now, but it will also look for anomalies, right? So we detect any weird patterns and things like that. So where you see here threat anomalies, if I left that scanner running, it would start to ping us there and start to worry. And you can see some of those examples here, like partner LB threats blocked anomaly detected value is 227. So it's picked up that there's been a spike in attacks and is, dealing with that, addressing that, etc. And that will send you an email. You can also get, a text message. So you can have it send you a notification. You can have it send you a Slack webhook if you want, and so on. And it will notify you of all these kind of things, right? So what I've shown you is kind of one of the most basic use cases, I guess, where we've just got this demo ADC. And we've got one ADC in it, and it's managing traffic, monitoring your latency. You can look at things like your IP rates, and we can look at performance and the WAF blocks there, and all of that kind of stuff. And you can run this on multiple servers if you like. But what I want to show you next is actually what we call an autoscaler. So it's basically the same thing, except that we want to allow Nova to decide how many instances to run for that system, right? So if we come here into autoscalers, we can say, okay, we want to create an autoscaler. It's going to be a cloud autoscaler, and we'll say here, website scaler, and we can create this. And now we can say, okay, let's base it off of DigitalOcean, that test DigitalOcean account we have. We're going to set it up in New York 1. We can choose a droplet sizing. So when we launch servers, how big should they be? In our example, we'll use the cheapest ones again. And how should we run? What should the minimum spare service be and the maximum service we run, right? So in this configuration, it's saying, well, run 2 at least, and don't run more than 5. Because you can control your spend. So I could say, okay, well, I don't want to run more than 10 ever, but I want to run at least 3, perhaps, right? So I know that my load, I never want to be under 3, but between 3 and 10, let Nova launch servers and shut servers down as it sees fit in order to handle any amount of load. So let's just do the smallest number. We can do 2 here, and we can update this. What this is going to do is automatically provision an autoscaler for us. So you can see here, we see that it's adjusting, right? So it's currently booting up or shutting down instances. It can take up to 3 minutes at most, depending on your cloud speeds. So as we saw earlier, DigitalOcean is running at about 60 seconds, I think it was probably. So we'll have those servers available. And what it also does is it creates a dynamic endpoint for us, right? So we've now been given an autoscaler destination automatically that will route traffic to those nodes. So if Nova boots up 10 nodes, that destination will automatically route traffic to all 10 nodes if they're online, right? So it will check their health, things like that. And if they are, it will send traffic there. And as we shut them down, we do the reverse, right? So let's say you've got 5 ADCs running, and we decide, well, you actually only need 3. We'll remove 2 from your destination. So clients stop getting given that via the DNS entry. And then 5 minutes later, those nodes will actually be shut down. So once we've bled them, removed all sessions on them, things like that, then we shut them down and terminate them. So we don't just power them off and you still pay, we actually just completely terminate them. And when we boot new ones up, obviously it's much faster. We boot them up, and then we send, as soon as they're online, we update the address. So you can see here we're starting to get servers coming online. A web scaler is just booted up, and we should have multiple coming soon. I can have a look in here, and you can see we've got 2 online autoscalers now in this group, right? So we have this one and this one that have been launched automatically for us. And you can see here expanding server pool by 2 servers to 2 total because the nodes running was less than a minimum. So it will now start to monitor those. And should they have too much CPU load, running out of memory, too many connections, if latency is building too high, it will expand that. And then once it becomes idle, it will delete them again and shrink it back in. And now, instead of attaching our ADC to a single node manually, we can rather say attach it to an autoscaler. So however many servers are running in that autoscaler, run this ADC on. And we've now got it configured and running. So you can see here, demo website is now running on 2 nodes instead of just the 1, right? And I can configure that as well. I can say, well, also do it on other servers and things like that. Like I could say, well, also run it on these servers as well as my autoscaler there. So you might have an autoscaler in your cloud account and also want to run it on your manual accounts and things like that. And if we have a look here, we'll have them on our nodes panel here as well. So there you can see it's being managed by an autoscaler, so you can't delete it. And you can actually delete the autoscaler, obviously. But if we come in here, we can see that server's info. You can see where it's located. You can see the packets it's received, CPU usage, memory usage, its specs, and all that stuff. And we can now monitor that server's health, obviously, right, to decide whether we need to scale up or scale down and things like that. And that's all handled automatically for you. So if I come back into autoscalers, we can see that again in here, where they still are and their status and so on. And they should settle shortly. So it just says adjusting. Now it says it's stable. So it's decided that it doesn't need additional resources right now, given the state that they're in, basically, right? So let's just run this on website scaler on that ADC group, right? And again, like I said, this is the autoscaler, which is so any servers we launch now, if this grows the server pool by 5, they will automatically get this ADC we set up, our website ADC. And it will automatically be managed, updated, the WAF is applied, monitoring, all that kind of stuff. And when we come in here, we can see here is our autoscaler that's running it, and you've got your stats just like you expect, right? So you've still got the same setup, etc. And you can see the multiple nodes. So as we start to send traffic to those, we'll see them now, instead of just having one device like we did before, we've now got multiple devices, right? That are just being synced with the config. So when we look at the autoscaler here, we can see, okay, this is the dynamic endpoint we were given, and we can send traffic to that. So again, we get our invalid SSL certificate, but then we can proceed. And so this is an auto-managed, fully qualified domain name for us that will always point to whichever online servers we have. And right now that happens to be 2 nodes, and we can see these servers here, and we can see that they've started to get traffic, right? Because I sent a bit of data to them. So you can see we're starting to measure response time, and as I send more and more traffic, we'll start to get requests graphing as well as soon as it's got something to show, basically. And if we come in here, we can see the actual response times of those servers and everything, just like we expect. So it has 2 nodes because it only needs 2 nodes now. But what I can do is I could say, okay, well, you should run at least 3. Right? So I don't want to run 2 anymore, I want to run 3. Now, of course, a large amount of traffic would cause this as well, but I'm going to manually say, well, I actually want 3 for this autoscaler. And that's going to pick up now that we need to boot more nodes. And so you can see here we've allocated a new node, and it's going to start deploying that system for us as well. So if we come into here, you can see it's obviously offline. It's still just being booted. And if we have a look at our cloud connection here, we should see a brand new server coming online. Yeah, drop launched, installing Nova to the system. So you can see we've now got 3 autoscalers, right? And it handles all of this automatically for you. You don't have to come in and say that. It will just do it, as the load determines. I'm obviously just faking that in order to get some more traffic to go through, to simulate, the need for more servers. And as soon as this launches, it will be put into our autoscaler destination, and we can just then, automatically have the traffic start going there. So you can see we can only see stats for it because it's an autoscaler, so you can't control it. And this should come online any second now. Yeah, we've got an online server now. So we'll now have 3 servers online, and it will autoscale across all 3 of them instead of just the 2 that we had before. And they'll all start to get traffic, and it will control all of that. And that's how autoscaling works, basically. So what you've seen are the core kind of components, if we just rehash this a bit, is nodes, which are individual instances in people's environments that we're controlling, right? Then you've seen us show the ADCs, where you have backends, where you control where should traffic be sent. In our example, we said we want to auto-discover web servers, but there are many ways of doing that. And then we created an SSL termination ADC, where we turned on the WAF, which we saw it protecting. We turned on scanner protection, which has blocked me, although I've been unblocked now because it's been more than 160 seconds or whatever we set it to. And we've seen autoscalers boot up new servers and send the traffic to them in order to handle increased amount of load. And that's essentially an introductory kind of preview of Nova. So there's a lot more features. There's blacklisting, there's whitelisting, there's a huge amount of settings inside the WAF and with clouds and with service discovery and your organization options and so on. Things like, your location view, where you can see where all your servers are. You can look at your inventory of your servers. So what performance do they have? You get graphs and reports and all that stuff for these things and so on. And you can obviously live monitor them and manage them and, see what's happening anytime you need. And all the time it monitors these, so you get notified if there's any problems, if any servers go offline, if there's anomalies detected. Like there you can see we had 100% CPU usage. Here we had threats, blocked anomalies, total connections anomalies, so anything that's abnormal that happens on the system. And it will monitor that and notify you of that and so on. And you can add multiple users here if you need. So, you have an organization and you can add in as many users as you need to the account. And that's essentially how you deploy a node. So in the most simple way, you set up a node like we did and you just attach an ADC. After that, you can obviously get more complicated by having multi-clouds, multiple locations, destinations, routing them around the globe, auto-scaling when you need it, the WAF, and all of that kind of stuff, monitoring your threats and so on. But ultimately, it's quite easy and quick to install. If you're doing a single installation or a single cluster, you can just come in here and create your node and attach your ADC. And if those nodes were ever to be lost, we've got 3 online now. If we ever lost one, we could just deploy it to a new one, right? So it's all entirely, the value, like I was mentioning, is all stored in the cloud because we have this configuration here. And you saw we can easily launch new servers. So by example, actually, we could even say, well, what if DigitalOcean just completely dies? Maybe we've got a disaster recovery set up in Amazon. So we can say here, Amazon example. And we might want to launch, let's just launch a cheap one. We can launch an instance in Amazon. And we can then route traffic to both of those clouds based on whatever rule sets we need and things like that. And this will, again, just like we did in DigitalOcean, this will launch an instance in AWS for us. It will connect back to Nova, and we'll then be able to do it. Now, to remember, you can obviously connect anything to Nova, any Linux system, any VM, anything like that, because you can manually install it. We're just doing this to show you, automatically installing on clouds. But as soon as this is online, we'll see it come up again, just like we have with the others. And we could then attach the ADC to that instance as well, right? So it will provide the same load balancing, etc., but in another cloud, all managed through a single location. So here we see Amazon's now online. And that's literally how long it takes to launch a brand new node and start load balancing. Here you can see our Amazon example. It's not an autoscaler, of course, and we can see where that is. So it's sitting over there. Very similar location, not New York, but I think that's Virginia. And we can then attach the ADC to the Amazon server as well. So, oops, I've gone to edit instead of deploy. So here, if we weren't saying website scaler, we could say, well, there and there and there and there, and it will deploy across multiple clouds, and we'll see all of its information and stats all here in our one control panel. The other things I should mention, obviously, there's an API for this, so you can automate it, you can script it. It's a REST API, very easy to use. You can create API keys anytime you need, give them access credentials and so on, revoke them, etc. It's a huge amount of functionality, obviously. The other thing you'll notice is that on a lot of pages, when you start to test the system, you'll see there's a docs link at the top right. See this little icon up here. You can click that and it'll go to a context-sensitive docs page for you. But there's a huge, if you just go to /docs, amount of resources about the types of ADCs, how you deploy them, the WAF, overview on destinations, where the DNS servers are hosted, all that kind of stuff. You can see everything here, installation instructions and so on. You can get as you need. Great, so that has been our demo. Don't forget, I'm going to answer questions in a second. So if you have anything extra to ask, please just pop them into the Q&A section. And also remember that on the website, there is a link, or you can just go nova-adc.com/demo, where you can actually schedule one-on-one time with our team. So we can take you through it, we can talk about your use case, we can help you install it, whatever you need. Okay, so I've got a couple of questions here. Okay, so the first one is, when do we expect Nova to be released? So it's in what we're calling now a technical alpha, right? But we are expecting a general release because we have had quite a lot of clients using it in our private alpha, obviously, for a while. General release between the 15th of October and the beginning of November is when we're scheduling it for. Between there, up in about the middle of between now and then will be the beta release, which has the next set of features coming out, like routing based on host name or path and things like that. There's some additional features coming soon. When will we be supporting more clouds? So we are adding cloud support basically the whole time. We're busy working on that, adding more and more clouds. We essentially have an API that we develop for each cloud provider in order to be able to do service discovery and to launch instances, droplets, whatever it might be, into their cloud. So the next one to have full support is going to be Azure. Then after that, probably GCP, Google's cloud. We're doing a direct integration with VMware products like vSphere, etc. And then after that, really, I guess we're looking at suggestions on what the next cloud should be. But even if your cloud is not supported, you can still obviously launch a Nova instance in that cloud by just launching a system and installing the Nova client on it. So you mentioned service discovery. So does Nova work with Rancher and Kubernetes too? Yes, it does. So in multiple ways. I know you're talking about service discovery, but you can run Nova instances inside Kubernetes. So inside pods, as containers, you can run it. And then you can also do service discovery inside Kubernetes, Rancher, Docker, Swarm, basically you name it, console, etc. So you can do service discovery for all of your containers that are running in there, as well as run Nova in there. Or if you're running Nova outside of your Kubernetes environment, you can still do service discovery into it. And that is it. If there are any other questions, just submit them quickly now. But otherwise, that should be it. Please, like I said, feel free to browse the website. This recording will be shared afterwards as well. And you can book a demo with us on the website, or you can sign up directly for an alpha account and start testing Nova yourself anytime you're ready, basically. Other than that, thank you for coming to the webinar. It's been great kind of interacting with everyone here. And we look forward to seeing you on the platform. And if there is any direct questions you just want to drop us an email, by the way, you can email us at alpha@nova-adc.com. And we look forward to seeing you guys on the platform. Thanks, everyone.